Hello everyone, good morning. Dear authors and invited guests, welcome to Technical Session 7F. Myself, Tanish Virmani, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all for the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held through Zoom today and tomorrow, which is 16th and which is the last day. Today is the last day, 17 December. I hope you'll all enjoy the knowledgeable and interactive sessions throughout the day. In these sessions, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. After 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, you can write to me in the chat box. Just before we start the session, I would like to introduce you to the chair for this session. Chair for this session is Dr. Vidyarani Krisagar, who is an associate professor and vice principal at FabTech Technical Campus, College of Engineering and Research, Sangola, Maharashtra. Her academic and research expertise lies in environmental engineering with a focus on biogas disasters and water and wastewater engineering. She is dedicated to advancing sustainable engineering solutions through teaching, research, and academic leadership. Ma'am, can we have some words from you?
Tanish, I guess the audio is not working for the session chair.
Yeah.
So,
Okay.
yeah, I just got a text, so maybe we can move forward for now.
So, do we start?
Yeah.
Sure. So, we'll start with the papers. The first author, uh, she's the chair. The first author we have is Zakaria Kita for the paper title A Stacking Based Model for Animal Disease Detection in Burkina Faso. So, do we have you?
Good morning.
Good morning. You can start your screen sharing.
Okay. Okay. You can see my screen.
Yes, it's visible.
Okay. Good morning. Thank you for this opportunity. I am Keita Zakaria Sheikh Omar, a PhD student at Naziboni University in Burkina Faso in West Africa. My English is not good. I will try to present our work titled A Stacking-Based Model for Animals Disease Detection in Burkina Faso. Alors, the presentation plan around of 5 parts. We have introduction, related work, methodology, result and discussion, and conclusion. Alors, according a World Organization of Animals Health, livestock farming contribute to 50% to the value of global agricultural production and provide livelihood for at least 1.3 billion people worldwide. In the Ministry of Agricultural and Livestock Farming in Burkina Faso, this sector contributes 14% to add the value of the primary sector and represent more than 4.1% of GDP. The sector faces significant challenge, including the prevention and management of animals' disease, which restrict its impact on overall socio-economic development. Uh, as an illustration, the avian influenza epidemic that occurred in 2022 result in the death of around 500,000 poultry and the loss of 1.3 million eggs trays. We think that veterinarians are needed to raise awareness among stakeholders and to implement prevention and rapid response measures. Unfortunately, 122 veterinarians are registered with the National Veterinary Office of Burkina to meet a need of 370. Alors, we think that artificial intelligence is a promising solution to automate the diagnosis. Alors, the overall objective in this study is to have a tools to aid in the diagnosis of animal disease based on artificial intelligence. Several work has been conducted to automate the animal's disease diagnostic. We have Selim and all determine the seroprevalence of contagious caprine pneumonia and identify associated risk factor using decision tree models. The results show that the decision tree models produced a better performance of 92%. Machado and Ollo propose a model to detect new cases of epidemic porcine diarrhea, focusing on pig movement between farmer and operating area. The model achieves 83% accuracy and random forest 80% for SVM and 79% for the gradient boosting models. Sagedi developed a new method for diagnosis avian disease based of thermography for data collection and artificial intelligence for analysis. The results show an accuracy of 97% with the SVM algorithm for avians influenza classification. To end, Husseini and Tito identify risk factor for brucellosis in dairy cow. The results show that the multiple perceptron achieve a correct classification rate of 97% compared to 94 for decision trees. Alors, despite their notable advance, they do not encompass all priority animal disease in Burkina Faso. In addition, local specificities such as geographical variation and climatic conditions often influence the manifestation of this pathology. Our architecture is composed around of three parts. We have a data collection and processing, a model construction, and solution usage. Alors, the data were collected in Burkina Faso, specifically in two cities, Bobo Dioulasso and Ouagadougou, by two teams, experts of veterinarians. After data collection, we have 316 observations corresponding to 36 diseases and 8 animal species. The variable include the animal species, body temperature, age, date of consultation, symptom, etc. For our study, we selected the 15 representative disease corresponding to the priority disease identified at the national levels. We have canine distemper, we have coccidiosis, lumpy skin disease, we have Newcastle disease, etc. Alors, after the data collection, we are making the data processing and apply the data augmentation. And at the end of this step, the data set listed to 2550 observations. To build our diagnostic model, we adopted the stacking method. We select and train different basic model, KNN, random forest, SVC, bagging, gradient boosting, ADAP boost, and XG boost. We use the prediction of the three best initial models as a new feature and train a meta model. The meta model combines the prediction of the basic model to produce a more accurate final prediction. Alors, the result show that random forest bagging and SVC obtains the best performance in accuracy, precision, and recalls. To build our stacking method, we select the three best model random forest bagging and SVC, and our final models obtains 99.1% in term accuracy. Alors, the evolution of our learning curve or final model show a limitation of risk of overfighting. The final model demonstrates exceptional performance of our stacking methods in a context of limited data. Despite previous research has shown promising results in this area, most of the diseases were limited to predict two, three, four, or just one without covering all priority animal disease in Burkina Faso. In addition, local factors such as geographic variation, climatic conditions often influence the manifestation of the disease. To our knowledge, this study is the one of the first in Burkina Faso to systematically diagnose animal disease based on clinical signs. A major limitation of this study lies in the unavailability and heterogeneity of qualities data used for model training, as well as the similarity of symptoms between the different diseases, which is a challenge. Despite the model show high accuracy, finally distinguish between disease in similar clinical signs can be difficult. To conclude, this research illustrates the potential of artificial intelligence in animal disease diagnosis in Burkina Faso and constitute a first step towards the development of practical tools to assist veterinarians in Burkina Faso. In our future work, we plan to integrate the visual aspect of this of the animals into the diagnosis process. Applying deep learning techniques to image and video could further improve diagnosis accuracy by capturing clinical details that are difficult to exploit based on reported signs alone. Thank you for your attention.
Any question from audience? Am I audible?
Yes, ma'am, you are audible.
Yeah. Any question from audience? If not, may I?
Yes, ma'am, sure.
Yeah. Kitia, that I have studied your topic, and I came to know that Burkina Faso is facing the issues or challenges about the limited infrastructure with respect to veterinary. What is your opinion? How AI can help to assembling the stacking models to improve the diagnosis and management of animal diseases in livestock? Is Kitia is there? Keita.
Yes. Hello?
Yeah. And do
I
you
don't
understand my
understand.
question?
I don't understand.
I'm asking how
Mhm,
AI-based assemble
mhm.
will help to stacking the models improve the diagnosis and management of animal diseases in your place, that is Burkina Faso.
Okay. We think that actually the diagnosis in Burkina Faso is making manually, and we have not a numerous veterinarians to make this activity. Donc, we think that with AI-based diagnostic models uh, can be improve the diagnosis of animal disease detection in Burkina Faso.
Okay, proceed. Coordinator can go for the next.
Sure, ma'am. Now I would like to call the next person. Next author is Ayushi Bisht for the paper title Accounting Frameworks for Non-Fungible Tokens Towards ICT Enabled Standards for Transparency and Governance. Do we have you?
I think Ayush is not there.
Yeah. So we can
Go for
go
the
with
next.
the next author. We have Debosmita Chaudhary for AI-based weather forecasting, a study.
May I start presenting?
Yes, sure.
Good morning, everyone. I am Debosmita Chaudhary from Sikkim Manipal Institute of Technology, and today I am presenting my paper titled as AI-based weather forecasting, a study. These are the contents I'll be covering today in the presentation. As we all know, weather influences our daily lives a lot, from taking an umbrella before going out to using sunscreen before going out. We check everything, and weather influences not only our daily lives but also agriculture and various risks in various areas. So accurate forecast is needed for informed decision making, but traditional techniques fail these days with rapidly changing climate. With improvement of various artificial intelligence and machine learning techniques, we can work toward achieving near perfect results in prediction. So what our paper does is exploring recent research works following the PRISMA guidelines to gain insights on the trend of technologies used for weather forecasting. And we also examine model performances to assess how each model contributes to improving the accuracy and reliability of weather forecasts. So this is a bibliometric study. We combined a bibliometric mapping using a systematic literature review. As I said, we followed PRISMA guidelines, and PRISMA means preferred reporting items for systematic reviews and meta-analysis. And it has distinct 4 stages, that is identification, screening, eligibility, and inclusion. Our literature reviews for this review, the literatures were collected from IEEE Explore, Scopus Index, and Springer databases. The time span covered was from 2012 to 2024, and we had distinct inclusion and exclusion criteria for each paper. This is how the PRISMA model looks. For inclusion criteria, we only took articles published in English language between 2012 to 2024, and only in indexed proper sources. For exclusion criteria, we let go of papers that were unrelated to AI-driven forecasting or lacking methodological transparency, or non-peer-reviewed sources, or articles published prior to 2012. From this study, we found out multiple techniques were used, starting from classic regression models to deep learning approaches like artificial neural network or recurrent neural network or masked encoders. Artificial neural networks, they capture non-linear relationships in atmospheric data, uses historical and real-time weather parameters, which is suitable for short and medium-term forecasting. Recurrent variance model temporal dependencies. For regression-based models, we saw that simple mathematical relationship between variables can be found using regression-based models. These were fast and easily interpretable, but the performance were limited for highly non-linear weather pattern. And as weather is not always linear, regression-based model did not perform that well. Then we had classical neural networks. For multi-layer perceptron, we saw it was effective for non-linear data, but as MLP is simple, but it needs more data, we saw that for small data sets, it has a problem of overfitting. For Elman recurrent neural network, we saw that it captures temporal behavior in time series data and it remembers the past data. So it is really useful to learn the data pattern and the weather pattern. For RBFN or radial based function network, we saw that fast convergence happened in for the short prediction time. For Hopfield network, we saw that it was used mainly for optimization, but not directly for forecasting tasks. Masked autoencoders, whereas where self-supervised learning with masked input reconstruction and it learns hidden structures, and it is robust because it can work with incomplete data. And as we all know that weather data is not always complete, so masked encoders provide stable and high accuracy even with incomplete and that type of missing data. This is a simple architecture of a artificial neural network, which is the basis of all the technologies that we just mentioned. That there is a input layer, then hidden layers, and then output layer. The hidden layers and input layers and output layers all are interconnected with each other. This is the table we made or we got from the survey. From this table, we saw that Arima, Anfis, they had really good results, and these are like hybrid models. Also, we saw mass encoders like WME had good results. This work combines various bibliometric trends with quantitative performance evaluation, enabling evidence-driven insights. Cross paper performance comparison independent of dataset size or region was done for better future references, and this was followed from the paper of Edward from 2024. They gave a formula to normalize the accuracies of same models used in different research works in the same kind of area. So we followed that formula to normalize the accuracies for our work and compare. The evaluation of accuracy versus computational costs and trade-offs were also presented in a tabular form in the paper, where we mentioned that ARIMA and SVM, those had like moderate accuracy, whereas hybrid masked encoders had very high accuracy. We also mentioned the strengths and limitations of the dataset. And we saw that neural architectures dominate weather forecasting research post 2018, and also after 2018 there was a rise in the field of weather forecasting. We also saw that strong geographic bias of datasets toward India, China, or Asian region than European weather. Limited focus was given on model interpretability and generalization in these works.
Excuse me,
For
ma'am. This is just a reminder that 9 minutes of the presentation are up.
okay, I'll finish. What future we can have from here is development of lightweight AI architectures, explainable AI models for improved transparency and trust, and also we can improve cross-regional data sets for better prediction and focus on efficient training strategies to reduce computational demand. And as for the conclusion, weather forecasting is critical, as I mentioned, and we can see that there are various dynamic conditions and complex work behind predicting weather. So AI-based approaches effectively can capture non-linear and temporal patterns. So we can use AI techniques to predict weather. These are the references, the main references, and the full reference is.
Debasmita,
Hello, ma'am.
yeah, have you validated this model with any of the data?
The models are validated in all these papers. What I did was using that 2024 equation given by Ebert above to normalize all the accuracies and compare them. As all the accuracies are not normalized, I followed that equation, solved that equation for each accuracy, the model accuracy given, and then compared and gave that result in a tabular form.
Okay.
Any more questions?
No, we are already delayed. We can
Okay,
proceed for
thank
the
you.
next thing.
Sure. I would like to call the next author, Sandeepan Ganguly, for the paper title Bangla Pro Stylo, a stylometric dataset of Bengali Pro corpus with sample authorship.
Am I audible, sir?
Yes, sir, you're audible.
Okay. Let me share my screen.
Sure.
Is the screen visible?
Yes, you are.
Okay. Respected ma'am, respected senior faculty members, and my dear research fellows, we are here to present our work on Bangla prose corpus creation and with a sample authorship. On behalf of my collaborator and student, Mr. Shubham Shahu, and my two guides, Dr. Shanta Foni and Dr. Vishal Bandyopadhyay, and Sandeepan Ganguly, presenting our work. So Bengali or Bangla holds a place in the ethnographic map, that is the ethnologue in the language ethnographic map, in the 7th position. But due to the very low resourced digital annotated resource, there is not much progress has been made in the areas of computational linguistics and natural language processing and all. So what we have done is that we have actually tried, that was the main objective that triggered us to create an annotated corpus, okay, and also made that corpus available for others. And we have studied that corpus for, we have made that corpus fade into the machine learning and deep learning algorithms to find out the authorship attribution. So this is the main content of my presentation. The author specification followed by methodology, data collections, the corpus statistics, sample one, and then data cleaning and the feature matrix that we have created, and the result analysis and all. So for our work, we have actually chosen 5 representative authors of Bengali languages, 5 archaic authors who were the luminaries during the Bengal Renaissance: Ishwarchandra Vidyasagar, Bankim Chandra Chattopadhyay, Rabindranath Tagore, Sharat Chandra Chattopadhyay, and Kazi Nazrul Islam. Their timeline is also being given because the author ID is specified according to the chronological order. And this is the methodological part of our work. So we have collected the data from the available sources. Actually, we have collected the data from the SNLTR website, that is the West Bengal Government IT Department website, and which actually holds the literary corpus of the ancient period, of the early period. And after scrapping those sources, we have pre-processed the data, then normalized with TF-IDF, and then we have actually created the TF-IDF matrix as our feature matrix, main feature matrix, and then fed this feature matrix into machine learning and deep learning models, and we have evaluated models, and there are corresponding visualizations. So this is actually the main sources of, as I mentioned, that this is a Society for Natural Language Training Research, SNLTR, which is a wing of the Department of Information Technology of West Bengal Government. That is our main source. And we have used several web scraping tools in Beautiful Soup and other Python-based library sources. Now, this is one sample statistics of author one, you can see that the first one being the statistics of all the authors, you can see of all the corpus that we have studied, their word, sentence count, punctuation mark, exclamation, interrogation, dialogue, and so on and so forth. So we have thought that within this framework of these intricacies, these stylometric features, the very foundation of the authorship is actually embedded. And the table at the bottom represents the genre-specific distribution of author one. Okay, actually we have done for all the authors, and we have also made that into as our feature. So this is one statistics. Now this is the corpus distribution of all the authors. Now you can see that the way we have got it, actually every author has their own volume of writing. So here you can see that the Rabindranath Tagore, his volume was quite large. So the actual database was highly imbalanced database. So what we have done in order to balance them, we have used both oversampling and undersampling techniques. Python-based methods are there. However, in this particular presentation, I'll be only showing the oversampled version. Okay, because in undersampling, there are significant amount of loss of information, mostly the semantic information. So here, the first part is the data cleaning and preprocessing part. Just a snapshot of our code. The stop word removed. There are defined Bengali stoppers. We have removed the stoppers, and then some of the non-Bengali and characters and other characters we have actually discarded using the regular expression formation. And you can see, so after this reprocessing has been done, so we have created metrics. Actually, we have created multiple matrices from 500, 750, and 1000 most frequent words, and made the TF-IDF and normalize the TF-IDF. So that's actually used as a prime feature of our work. Okay, the prime TF-IDF feature. Now that feature is actually made into, we have actually used several models. Actually, I have again shown 5 good results of the 5 models: SVM, random forest, multilayer perceptron, and XLNet. XLNet is a transformer based, somewhat current model, but we have tuned the parameters in order to make work into Bengali. So you can see the corresponding results, and we have got very good results in the case of SVM and random forest. Now this is the corresponding confusion matrix of different models that we have actually worked with. Now, this is the performance comparison between models. You can see that SVM has very good performance in terms of accuracy, precision, recall, and F1 score. And you can see that the other models. And XLNet is relatively new model, and it is not yet tuned to work in Bengali, but we are actually tuning that not to work in Bengali. But so far we have got this result, almost 92.46% of accuracy and all. Now, this result is significant because you can see that when we have plotted our results according to different author, so you can see a sharp contrast between other authors and Rabindranath Tagore, because Tagore has a very large literary career, and he's from the very early days of his life, almost his last. So the change of his stylometric fashion was very large. So all this nuanced fashion of change of stylometric feature, which is embedded in his prose style, we think that we have caught it quite accurately in our model. That means the aesthetic features, which is embedded within the literature framework, can be caught into the mathematical means through the means of machine learning. We have done so far this result in terms of XLNet. And this is the same visualization of XLNet in terms of we have plotted and heat map here. Here also the sharp contrast between other authors who has a kind of archaic fashion of writing, the same kind of way of narrative framework that they have used in their writing. But here in Tagore actually used so many nuanced variation in his writing from the early days of his creative life, from the very last. So that is very much caught in this particular work. And this is the overall summary of our work. So we have seen that we have got kind of very good results in random forest and SVM and other works also. get almost the bad results we have got is in Excel. That is also 92%, and we are still in the process of tuning our models, and also we are in the process of giving more features, that is n-grams and other features. Okay, that is a current work that we are doing, and for even larger database. And so the scope of our work, I mean, for future scope that we can extend our work, is that we can mathematically analyze more nuanced expressions in Bengali literary corpus, and we can do the sentiment analysis of the literary corpus we can have. And there are other models, there is contemporary models, that is BART and other contemporary, mostly deep learning, transformer-based models that we are tuning right now in order to cope up with nuanced Bengali literary features, and which is the current work that we are doing right now. And hopefully we can be able to do much more larger corpus. That is the very early days of the formation of Bengali language. The very archaic features, the very nuanced archaic features, we'll be able to catch when we will make this particular database available, and we'll work that into the current contemporary models. Thank you all.
Very nice, Ganguliji. Actually, when I read your abstract, I had a question how that machine learning and deep learning models will identify the different writing styles of the Bengali literacy. But with your presentation, I'm clear with this. Very good.
Thank you, ma'am. Thank you, ma'am.
We can go ahead.
Sure. Now we would like to have the next author, Shubham Jasta, for the paper title CBDC in Emerging Economies, ICT, E-Governance and the Future of Monetary Policy. So do we have you?
Yes, sir. Yes, sir.
Sure. You can start your screen sharing.
Okay, sir. Wait. Sir, actually, I am unable to share my screen.
Your screen is visible actually.
All right, friends. Good morning, everyone. Today, I am going to present my topic on CBDC in emerging economies, ICT, e-governance, and the future of monetary policy. So, as we all know that ICT has changed the perception how we used to work in our daily lives. In digital, in financial system also, ICT has changed the perception. Look, as we all know that in India, UPI has changed the way we used to payment earlier. After the COVID pandemic, we have seen disaster changes in the system of digital payments. So services in the daily life in each field, advancement in technology has made services convenient and easy. One of the newest invention in that field is CBDC, Central Bank of Digital Currency. Currently in India, it is in the pilot stage. CBDC is of a couple of types. One is retail services and another is wholesale services. As regulated by central government, it can improve transparency and achieve the goal of financial inclusion, but still security, privacy and trust remains a major concern while operating in digital services. Based on the previous studies, we have concluded the several objectives of the studies. The main objective of the studies that how ICT, computer technologies, can improve the adoption of CBDC and how it can improve the trust among peoples of the country. So the main objective of this study is to how emerging economics like India is prepared to adapt the CBDC and what are the key factors that drive the adoption of CBDC and what are the barriers in its adoption. So to examine the scenario, we have prepared a questionnaire and the questionnaire was circulated to 350 respondents, out of which 130 have properly filled the questionnaire. The questionnaire was circulated based on the random sampling. And after that, PLS was applied on that questionnaire. This is my questionnaire. These were the independent variables of the studies, and adoption of CBDC were dependent variable. Regulatory and legal framework strength were my moderating variable, and public trust in digital currency was my mediating variable. And these were the findings of the results. The text in the yellow was my questionnaire, and the values between circle and yellow part is my correlation coefficients. As all the values are above 0.5, that means that my results were statistically significant for further studies. And the values between both yellow circles is beta coefficient. Public trust in digital currency and adoption of CBDC shows a major thing that beta is higher. So there is a high, strong, statistically significant relationship among these factors. And other factors like ICT infrastructure readiness, e-governance, and policy support shows less beta coefficient. That means they are significant but weak. And regulatory and legal framework doesn't show direct relationship with adoption of CBDC. That means that there is not significant relationship among them, but it enhances the adoption of CBDC if it is connected with e-governance. And these are the results of the path coefficients, and the result shows that maximum values are below 0.05. That means that ICT somehow, if it is interconnected with other factors like public trust and digital platforms and other regulatory functions, laws, it can be helpful for the adoption of CBDC. But the major concern still remains the security and privacy of peoples. So trust plays a major role in the adoption of any digital platform which we have to introduce. And this is the results of HTMT. HTMT shows the result of difference among the variables. And out of 10 variables, 9 variables values are less than 0.9, which shows that these HTMT is applicable and value should be less than 0.90. Out of 10, 9 values are 0.90. So our data is different. It can be applied for interpretation. But the major factor is trust, which plays a vital role in adoption of any digital platform that can be implemented. So the conclusion of the study is that ICT somehow is important for the adoption of any digital platform, but trust is a major factor among all. But interconnectedly, they all serve as a parameter for the adoption of CBDC. Thank you. Any suggestions from anybody?
Thank you so much for the presentation. You may stop your screen share.
Okay, sir.
Yes. Now we would like to have the next author, Sanket Shah, for the paper title, Depression Detection and Severity Assessment using PHQ-9 scale and machine learning models on clinical data from psychiatric patients.
Yes, sir. I share my screen.
Yes.
Is it visible, sir?
Not right now.
Now?
Yeah, it's visible.
Okay. Just a minute. Good morning, everyone. Good morning, chair, sessions, expert, and fellow researchers. My name is Sanket Shah. I am a research scholar at GLS University. Today, I will present our work titled Depressions Detections and the Severity Assessment using a PHQ-9 scale and a machine learning model. This study is jointly authored with the Dr. Trupti Dodia and Dr. Nisha Prajapati. And I would like to say this work is associated with the government hospital, Civil Hospital Ahmedabad. Uh, so we know depressions today affect more than 300 million people globally, making it one of the most common and the disabling mental health conditions. Its consequences extend uh, to daily functionings, productivity, and even a suicide risk. Traditionally, uh, Traditionally, depressions can be a measure like a manually assess. We can just manually assess this, right? So we can say that traditional methods like a clinical interview and the manual PHQ-9 score, while it's a very time consuming, subjective, and often not scalable, especially in a crowded place, right? Because in a government hospital many patients are there, so especially in a crowded healthcare setting it's not scalable. So in this context, combining ICT and the machine learning create an opportunity for automated, fast, accurate depression screening, which is a core motivations behind this study. So let's discuss the problem statement. So in our clinical observations, we found three major gaps. First one, a manual PHQ-9 scoring is a slow and inconsistent in a high volume clinics. Second one, existing ML study often rely on the population's level data set, not a real psychiatric patient's data. That means they are always download the data on the Kaggle. They are not working on the real world data. And the third one, very few models offer the severity-based recommendations, making them a less useful for a clinic psychiatrist or clinicians. Thus, our objective was create a clinical grade ML systems that can predict a depression severity and also guide a clinical decision. So we read lots of paper. So several studies show a promising result using a machine learning for a mental health. For example, Exhibit Boost with Sharp provide the high interpretability for a PHQ-9 dataset. Ensemble model in a general outperform for the conventional classifier. However, most of the study do not direct a clinical psychiatric PHQ-9 data, and the very few attempt to convert a predictions into a meaningful recommendations. So this gap is motivated us, even me, to conduct this research with the real world hospital data. So our data set was collected from psychiatric department at Civil Hospital Ahmedabad, Gujarat, one of the largest public hospital in the region. So it include a 208 patients, age is 13 to 59. Uh, all the patients completely standardized a PHQ-9 questionnaires, which is a DSM-5 aligned and widely validated. This study was conducted under the Institutional Ethics Committee approval. This give our study both clinical depth and ethical reliability. After ethical committee approval, we will start to collect the data. Why the sample size is 208? Because they are allow me to work with the sample data, right? Even here I mentioned the ethical committee ethical approval number, right? So then later that will be provided by the government hospital. So the PHQ-9 generate a depression score between the 0 to 27. Uh, it's a categorized individual into a minimal, mild, moderately severe, and a severe depressions. Interestingly, in our dataset, more than 74% of the patients fell into the severe category, which reflect the high clinical load at the government psychiatric department. If I'm talking about the methodology, uh, This slide we show that the complete architectures of the systems. This is the complete architectures we designed for the automatic depressions detections. Uh, Detections and the clinical recommendations. The process begins with the PHQ-9 questionnaires, which consist a 9 standardized questions. Patients typically fill out during their hospital visit, or it can even a self collected or a mobile device, or we can use one of the we can do via Google. Once the response are captured, the system perform the data pre-processing. These include converting a PHQ-9 responses into the numerical features vectors, validating the completeness, and putting a demographic information if needed, ensuring the data clean and consistent. Since the PHQ-9 use the uniform response scale 0 to 3, pre-processing become efficient, reduce the risk of noise or variability. The clean features vectors is then passed into the machine learning classifier modules. So we train 5 different algorithms for this: light GBM, XGBoost, random forest, decision tree, and support vector machine. The system evaluate these models and select the best performing one in our the light GBM. We achieve the 97.62% accuracy and the highest macro F1 and the kappa score. The classifier then predict one of the 5 depression severity: minimal, mild, moderate, 3 severe, and severe. But our systems goes beyond the predictions. The next stage is the recommendations. So this is the architecture I already told you. Which convert the model output and into the clinical meaningful guidance. If the output, if the depression is the severe, so urgently our model refer the psychiatric numbers. Uh, if the moderatively severe, they provide the counseling. If the moderate, then schedule the clinical follow-up. If the mild, so we give the lifestyle interventions. If the minimal, so routine monitoring, we will provide the guidance. So if I am showing you, so these 3 models, so light GBM achieve the 97.62% accuracy. Even the micro F1 is the 0.97, and the Cohen kappa is the 0.9 This number indicate not a high accuracy, but the strong agreement across all the severity class. XGBoost and forest also perform well, while a decision tree and HPM struggle with the multi-class complexity. So the key result is the light GPM consistently outperform all other models. It was especially a strong minority class like a minimal and mild depressions, and important features for the sensitive clinical screening. SVM performed poorly, suggesting that depression's severity does not separate well in a linear decision boundary. So here I have also mentioned among the total 9 questions is there in a PHQ-9. So the feature important analysis revealed that a 3 PHQ-9 item contribute nearly 60% predictive power, loss of interest, feeling down, and fatigue. These are the clinically recognized core symptoms of the major depressive disorder, which validate a model interpretability. So, as I told earlier, so if the our recommendations here, if the score is in between the 20 to 27, so urgently psychiatric evaluations is there, or give the telepsychiatry number. If the moderate, then counseling 10 to 14, then it's a moderate, so clinical consultation plus follow-up. If the mild depression, so we give these lifestyle change suggestions, or periodic screening is also required. And the minimal depression, so 0 to 4, so we have to provide the simple monitoring. The limitation is the sample size. We are working
Excuse
on
me,
the
Sanket.
sample size. Yes.
Your time is over. Please wait.
Okay. I just want to just
Yes,
if
please,
any
please.
question is there. I just want to just tell only last thing. Here we are working on the PHQ9, but in the features we are working with the other skill SBQR, SSQ6, and Bergen Social Media Addiction Scale for the suicide and the social support assessment. And so based on that, psychiatrists can be evaluated the patients in the all the directions. Okay. So any questions from the audience?
I think no question. Organizer can call for the next
Yes, yes,
person.
sure, ma'am.
Okay. Ma'am, any questions from your side?
Actually, I was discontinued for certain time.
Okay. Thank you, ma'am.
I could not listen you completely. Sorry.
Okay, thank you.
Yeah. The next author we would like to call is Lavi Garg for the paper title Driver Drowsiness Detection in Indian Vehicles with Face Obstructions.
Yes, thank you so much. Let me share my screen.
Yes, sure.
Is it visible?
Yes, ma'am.
Good morning, everyone. I am Lavi Garg from Dharam Singh Desai University. And for today, my research topic is driver drowsiness detection in Indian vehicles with face obstructions. So, road safety in India is a critical global issue, and driver drowsiness remains one of the most silent yet deadly contributors. In India alone, road accidents claim over 1.7 lakhs lives every year, and a significant portion of this is due to driver drowsiness. Due to drowsiness, the driver has a slower reaction time, poor judgment, and often fails to respond to sudden road conditions. This makes early and accurate detection of drowsiness extremely important. While many solutions currently exist, most of the current systems struggle with real world Indian conditions, real world driving conditions. So these are some literature review that we have studied, and the research gap that we identified was that most of the models are trained on controlled data sets. They assume good lighting, they expect clear and unobstructed faces, and use fixed camera angles. Moreover, they also lack ethnic and age diversity. However, Indian drivers frequently wear specs, sunglasses, caps, face masks, etc. And uh, not only in cars but also in other vehicles, this detection system is needed very much. So, as a result, most of the models that are currently existing uh, failed are failed due to lack of generalization. So, the key aspect of our research was that we collected a data set ourselves to build the gap between incorrect or lack of varied images. So, this is our system architecture. So, for our proposed model, basically, for the input, we will input some images that will be captured live while the driver is driving. These images will be standardized. They will be augmented. Their face will be detected. And then our model would be able to predict whether the driver is drowsy or awake. Coming to our dataset details, our dataset total consists of 10,000 images, out of which 72.59% images were self-collected and 27.41% images were taken from two publicly available KL datasets to ensure that we cover all types of images. So for our subjects, we total chose 27 individuals that comprised of 14 males and 13 females, and their ages were between 20 to 60 years. So this age and gender diversity was crucial because drowsiness manifests differently across age groups and genders. Secondly, we captured images not only in cars but also in buses with real bus drivers. So we did this using the local state transport of Gujarat, that is GSRTC buses. Next, we captured the images in different lighting conditions for daytime, for nighttime, even under the street lights, and when the sun was up, and when there was no glare. Also, next we used facial obstructions like sunglasses, specs, caps, face masks, especially after the COVID pandemic. It is very much expected that the face of the driver it would be obstructed due to a face mask. Next, we captured the images from many different angles, like the right side view, the left side view, in front of the steering wheel, from the dashboard center, and even from the rear view mirror, so that our model could work regardless of where the detection camera is mounted in the vehicle. So the data set was balanced equally, 5,000 images of awake drivers and 5,000 images of drowsy drivers, preventing any class imbalance during the training. So this is a sample of our data set. As you can see, some of the images are self-collected and some images are taken from the existing data sets. So first, we tested our data set on some pre-trained models like ResNet 50, Inception V3, and VGG16. So for that, we chose the parameters same for all the models. We froze the base layers to retain the pre-trained weights. We used Adam optimizer and binary cross entropy, and we trained for 10 epochs to see whether it was working or not. But as you can see, the accuracy for ResNet 50 was just around 55%. The accuracy for Inception V3 was around 77%, and the accuracy for VGG16 was way less, below 65%. So, due to this, the lack of performance of pre-trained models, we designed a custom CNN model. In this model, we first resized the images to 224 cross 224 pixels. We used hair cascade for face detection and cropping. Then we performed data augmentation. In that, we used various techniques like brightness variation, zoom, shear, horizontal flip. As you can see, this is the original image. This was the pre-processed image, and this is then the augmented image. The augmentation was done on the fly. Then we also have RGB to grayscale conversion to classify better for a night versus day. Next, coming to the CNN model. We used 4-layer CNN model.
Excuse me, ma'am. This is just a gentle reminder that 9 minutes of the presentation are up.
Okay, let me just quickly complete it. We split the dataset into 3 parts. 70% of the dataset was used for training, and 15% for validation, and 15% for testing. These are the details of our model. As you can see, the accuracy of our model was way higher than the pre-trained models. It gave an accuracy of 81.73%, and the AUC curve gave a score of 0.82, which is a very good score. Then we can see that the recall values were 75% and 89% respectively, and the F1 scores are balanced at uh, 0.8 and 0.83%. The confusion matrix shows that our model correctly classified 554 awake cases and 649 drowsy cases with relatively few false positives and false negatives. That is particularly significant because the data set we achieved this on includes very challenging conditions. This is the comparison table of how the models performed altogether, and you can see the performance of a custom CNN exceeds the performance of the pre-trained models. There, so these are the limitations of our model. Currently, we are only testing it for static images, and due to a few of the subjects were overrepresented, that may lead to a potential bias, but we plan to correct this in the future by expanding the dataset for more diversity and generalization. Moreover, more better models can be used for continuous monitoring and a video-based analysis. So, in conclusion, by achieving 81.73% accuracy and 0.82 of AUC, we have shown that custom solutions designed for specific and regional contextual requirements can outperform generic and pre-trained models. This research has the potential to contribute meaningfully to reduce the road accidents. And
So too late.
yeah, that's it. Thank you. Are there any questions?
What readings AI can read and understand the drowsiness of driver in real time?
Sorry?
What are the indications AI can read and understand the drowsiness of driver in real time? Is you
So,
have shown. Yeah, continue.
For that, there were many parameters for that. The eye-related cues for like eye closure, slow blinking, and reduced frequency. Then we also included some images that were
Okay.
yawning.
Then what
So
is the
yeah,
time span required for identification, then the corrective actions for the same? Have you worked on
time
that?
span.
Identification and then corrective actions.
I'm sorry, ma'am, your voice is breaking.
I'm asking, yeah, what will be the time span required for the identification and then corrective actions? Have you worked on that?
Okay. Right now, we are not working on video frames, so we don't know actually if we convert it to video-based analysis, how much time it will take. But for now, it was not taking much time for static images.
After that only you will be able to compete for the real-time users.
Yes, ma'am.
Okay. Next, please.
Yes, ma'am.
Thank you so much.
The next author I would like to call is Aparna V for the paper title Gaze Speak, a multi-model AI-driven human-computer interaction system using eye gaze and voice commands.
Yeah, thank you, sir.
Yes. You may start your screen.
Okay. Is there my screen is visible?
Yes, it is visible.
Hi. Good morning, everyone. I'm Aparna, and my fellow co-authors is Anisha Jain and Subhalakshmi, and we have faculty member with us, Ms. Aruna. In this work, we present a hand-free desktop control systems that runs on a normal computer using only a webcam and a microphone. Our system focuses on ability and inclusive design so that people cannot always use a mouse and keyboard where they are going, so they can still interact efficiently with the computer without expensive hardware. So these are the content I may be taking you through. So our problem statement is the problem we address in our traditional desktop interaction is centered around a mouse and a keyboard. So for many users is fine, but for people with motor impairments or in a hand busy situations like hospitals and lab, it can be a real barrier. Existing commercial eye tracking solutions are often expensive and need specialized hardware. So, our motivation is to use a modern AI, especially computer vision and a speech processing, and run it entirely on everyday hardware. So, the goal is to design and evaluate a multi-modal Python-based system called GazeSpeak that combines gaze and voice for practical hand-free desktop communication and controls. So, the core idea of GazeSpeak is simple but yet powerful. We use gaze speak to move. We use eye gaze to move the cursor and detect clicks, and we use speech for richer command such as typing, shortcuts, scrolling, and opening an application. And we can also search we can search on that. And both modules run continuously on a mechanism ensures that they do not fight with each other. So the main features includes voice controlled eye mouse on or off, a typical mode where spoken phrases are typed into an active window and commands to open a common application and also add a web search and YouTube search for spoken queries. So our contributions are first, a multi-modal gaze plus speech desktop assistant implemented entirely in Python. Second, a thread architecture that uses shared flags for conflict-free control. And third, a user study with 20 participants testing the system under different lighting and different noise conditions. So this is our system architecture where we take both input as webcam and a microphone. The input layer includes a standard webcam that supplies video frames and a microphone that supplies the audio stream. In this processing layer, the visual processor uses OpenCV and MediaPipe face mesh to detect facial landmarks. From these, we can extract eye and eyelid position. Landmark coordinates are mapped to the screen coordinates for cursor movements. Parallel to that, the speech processor uses speech recognition library with the microphone stream. It performs noise adjustment, converts the audio into the text so that the text detected commands like start mouse, open Chrome, scroll down, or you can also type search Python in Google. So in a control layer, our component uses a shared flags like mouse enable listening and typing mode to coordinate both modalities. Finally, the controller uses PyAuto GUI to execute actions such as moving the mouse, clicking, scrolling, and pressing shortcut keys or opening, closing the application. So in this slide, we have implemented, in the implementation point of view, everything is done in a single Python code. We rely on a familiar libraries like OpenCV, handles webcam, MediaPipe, face mesh, gives the precious facial and landmark expressions. So the code structure is as follow. We define a voice assistant function which runs in a separate background thread. It continuously listens to the microphone, recognizes speech, and using Google's engine, convert it to a lowercase text, and then matches the text against the series. It rules the trigger typing shortcuts, app launches, and toggling the iMouse. So the main thread runs the iMouse loop. It reads frames from the webcam, applies face mesh to the landmark, calculate gaze position for the cursor movements, and use eyelid landmarks distance to detect blinks and generate clicks. So both the threads shares a few global variables like mouse enable listening and typing mode, which forms a simple but effective mechanism. So then we go to the methodology and algorithm flow. We first initialize all resources like webcam, microphone, text-to-speech engine, and face mesh model. Next, we start the voice assistant thread as a demo so it runs in a background. In the main loop, we continuously capture webcam frames, flip them, converts into RGB, and pass them to face mesh. It is at least one face is detected and the mouse enabled flag is true. So we map a chosen eye landmark to the screen, coordinates and move the cursor. We also monitored eyelet landmarks to detect blinks and trigger clicks. In voice thread, we periodically adjust for ambient noise, listen to the microphone, and run speech recognition. Recognized text is also matched in our command set and translated into actions like typing, opening websites, and to the action. So, kindly, all actions are executed with Auto GUI, and the user can overlay indication whether the iMouse is currently on or off. So, here the experimental setup. For evaluation, we record 20 participants aged between 18 to 60 with a mix of background like mobility abilities. All experiments were conducted on a single laptop with a HD webcam, built-in microphone. No additional hardware was used. We test three main environmental conditions in normal light, low or dim light, and a high background noise such as background music or people talking. Like participant performs a set of tasks that reflect everyday uses, moving the cursor to the specific target using a gaze, clicking via blinking and opening applications like Chrome, Notepad and with voice commands, scrolling pages up and down using speech, and typing short sentences by saying start type or type, dictating text and saying stop. So these are the experimental setups. Now, results for cursor movements, latency remains around 64 milliseconds in a normal condition, slightly higher in a low light and similar in a noisy environment. This is enough for the user perspective. Cursor motions are smooth as responsive. Blink-based click accuracy reaches about 95% in normal light and remains about 89% even in a low light and a noisy conditions. This shows that blink detection is robust, although lightning does not have some effect. Voice command accuracy is about 97% in a normal condition and 95% in a low light. As expected, high noise reduction recognition accuracy is about 86%, but the system remains functional. Modularity switching between gaze and speed happens in roughly like 187 to 215 milliseconds, which is user reported as fast and natural. Overall, the system maintains good performance under realistic vibration and environment. So these are the outputs of a system. Like when our system is on, we have to say like iMouse on. It will show a display message like iMouse is on, and we can also perform like scroll up, scroll down actions. And next we can say like open Chrome, and our system listens and it will open our Chrome. So like we can also say like open Gmail or open YouTube and like that we can say. Like we also can search in Google, like search Google and search Google PY. Like we can search Python and Google. So like a similar way we can also like type in the ChatGPT box or like we can perform some actions. So at last we can say like the mouse is off. It says that the mouse is currently off. And we go to the user feedback. We also collected subjective feedbacks using a linker scale questionnaire. Most participants strongly agree that our system is easy to use and they confidently feel using eye controls after a shorter training period. They also reported that the speech command were usually detected accurately, especially in a quieter condition. Importantly, most participants said they would be happy to use GateSpeak daily, particularly for accessibility and hand-free busy tasks. So, I'm concluding that GateSpeak demonstrates that we can build a practical multi-modal hand-free desktop control system using just a webcam, a microphone, and a Python AI automation library. Our evaluation shows low latency, high click and command accuracy, and encouraging user feedback in terms of usability and accessibility. This makes the system especially beneficial for users with motor impairments and for hand-free busy environments. Our future work includes improving gaze tracking robust in low light for better and custom speech model for noise and accents, adding per user calibration, expanding the command set multi-language support, and integration GateSpeak with IoT devices such and possible mobile platform. Like, thank you all for your attention, and we are happy to answer your questions.
Aparna,
Yes, ma'am.
how this system exactly differs from the existing gauge speech interfaces? There are
Yeah, ma'am.
different gauge speech different interfaces
Yeah,
in the
ma'am.
market.
Yeah, ma'am. The existing system is only focusing on one modality, like they are focusing only on gaze and they are converting text recognition. Like we perform the text actions, like we can say like opening Chrome. Our system like really modularity, like we prioritize the text into speech format. Like we can give and perform actions, ma'am. Like this is the thing that we
No,
differs
that
from the
Siri
others.
is working for both, no?
Sorry, ma'am.
Siri is working for both Siri model.
Ah, yeah, ma'am.
Then
Like
how your model is different than this?
like yeah, existing system is only focusing on eye movements, ma'am. Like we combine both gaze and speech. Like we can also
Okay.
perform
Yes.
both similarly.
Okay.
Thank you, ma'am.
Yeah. Next, please.
Yes, ma'am. The next author I would like to call is Alisha Salim for the paper title ICT Driven Efficiency and Worker Well-being, examining algorithmic management and satisfaction in quick commerce ecosystems. Ma'am, do we have you?
Yes, sir. Good morning.
Good morning. You can start your screen share.
Okay, sir. So is my screen is visible?
Not, yeah, it's visible.
Yes. Good morning. I'm Alisha Salim from Graphic Era University, Dehradun. And my paper title is ICT Driven Efficiency and Work Wellbeing Examining Algorithm Management and Satisfaction in Quick Commerce Ecosystem. So, as we all know, in today's world, quick commerce is a most essential part of our lives because if we are sitting somewhere, so we can order a product within 10 to 15 minutes, as we all want. So, my paper revealed that ICT has transformed the work environment in quick commerce enabler delivery within 10 to 15 minutes. Platform really have rely heavily on algorithm management for task allocation, route optimization, and performance tracking. Technology improve efficiency, constant, and operational speed. Algorithm helps structural workflow and maintain several qualities. These are my research objective. Examine the effect of algorithm management on gig workers' job satisfaction. Second is measuring the role of ICT system efficiency. Third is test perceived fairness of platform operation as a mediator, assessing digital literacy as a moderator. And this shows my literature review, and it is my theoretical framework. My independent variable is algorithm management, ICT system efficiency, mediating is perceived fairness, and moderating is digital literacy, and it rely on dependent variable, which is job satisfaction. Next is these are my hypotheses. There is a significant impact of algorithm management on gig worker satisfaction. Next hypothesis is there is a significant impact of ICT system effect on gig worker satisfaction. Third is perceived fairness of platform operation mediate the relationship between algorithm management and gig worker satisfaction. Fourth is perceived fairness of platform operation mediating the relationship between ICT system efficiency and gig worker satisfaction. Fifth is digital literacy, moderating the relationship between algorithm management and gig worker satisfaction. Digital literacy moderate the relationship between ICT and system efficiency and gig worker satisfaction. This is my last hypothesis, sixth hypothesis. And my research analysis has been done on primary data, where I have collected the data from gig worker, delivery workers from apps like Blinkit, Swiggy, Zomato, and Rapido. And my sample, I have distributed my questionnaire to 250 respondents, where out of which 115 was validly responded and filled correctly. So I have taken my sample size of 115, on which I have applied PLSM, smart PLSM, and I have measured my question on 5 Likert scale. This is my data analysis. This is the PLSM algorithm model, which shows algorithm management and ICT system efficiency has a higher impact on the dependent variable, and digital literacy and perceived fairness has a moderating effect on the dependent variable. Moderating variable has a minimum direct effect on the dependent variable. Next is path coefficient model. This shows Cronbach alpha value for all construct which is greater than 0.5, and average variance is greater than 0.5 of all construct, which indicates strongly construct reliability and validity. This is my this is my path coefficient model. Algorithmic management and digital literacy are improving gig worker and have strong impact on efficiency of ICT. And I have already explained my validity and reliability model. And conclusion. Algorithm management, digital literacy improve work satisfaction mainly through perceived platform fairness. Algorithm management and digital literacy shows a direct positive impact on work satisfaction, while ICT system efficiently has a limited effect. Perceived fairness of platform operation act as a key mediator, and digital literacy moderate technological effects with more digital skilled worker experience better outcome and higher satisfaction. And my paper limitation were region specific sample size and cross section design and respondent data. We can do future research in longitudinal algorithm challenges, cross culture context, and fair fair and personalized algorithm design and broader gig sectors. Thank you. Any questions?
No question from my side. Please go ahead.
Thank you, ma'am.
Thank you for the presentation. Now we would like to call Ayushi Bisht, the only presentation which was left. Ayushi Bisht for the paper title Accounting Frameworks for Non-Fungible Tokens towards ICT Enabled Standards for Transparency and Governance.
Yes, sir. Good morning, sir.
Good morning. You can start the screen share.
Okay, sir. Sir, is this visible?
Yes, it is visible.
Okay, sir. Good morning, all present members here. I am Ayushi Bisht. I am a research scholar in Graphic Era deemed to be university. Today, my presentation topic is Accounting Framework for Non-Fungible Tokens towards ICT-enabled standards for transparency and governance. So basically, this topic is mainly deals with NFTs and their accounting frameworks. NFTs basically are unique digital assets. This could be any image, any music, anything which are non-replaceable, and these are powered by blockchain technology. Blockchain technology is basically used for securing the data and storing that data in a secured and in a safe manner. Traditionally, there are various accounting standards which are designed for intangible assets and various physical assets, but there is no such any specific framework or standard that is related to NFT. So there is always a question in a mind of a accountant that they always struggle to decide whether NFTs are inventory, intangibles, or investments. Therefore, there is also an absence of dedicated accounting framework. That's why this study narrates the need to align NFTs with existing accounting principles to achieve transparent and reliable reporting. And this is the process of creating NFT. First, we have to create the artwork that should be unique, that is non-replaceable. Second, we have to select a marketplace where we have to sell this artwork. Next, we have to create crypto wallet. Crypto wallet basically a digital tool that enables you to manage, send and receive NFTs. by storing them securely. And the fourth one, we have to connect the wallet to a marketplace. Then we will upload our artwork to this marketplace, and finally we list our NFT for sale. So this is the process, and here is the research objective of our paper. So basically, we want to explore here the influence of various factors like government policies, taxation rules, ICT infrastructures, and legal framework, all these items, on adoption of ICT enabled NFT accounting standards, because there is no such specific accounting standards that are dedicated to accounting for NFT. That's why these are the research objectives of our study. The next slide talks about, these are the literature review. Basically, this is the crux of the literatures I have studied for this conference paper. So here, these are the crux. Here we can say that although the adoption of NFT is increasing, but still most of the literature here talks about uh, the technological aspect of NFTs, and there are very few literatures which talks about the accounting practices for NFTs. Therefore, there are various suggestions. There are the studies which also recommend that firms should adopt the fair, standard, and accounting disclosures to ensure transparency, and which also protect investors. And there should be various trainings that should be given to finance professionals that improves auditability and also the trust of investors. And the next one is research methodology. Here, basically, we have prepared a questionnaire that is circulated to relevant respondents like finance professional, accounting professionals, and various researchers. We have sent this questionnaire to approx 200 people, but we have got the response of only 112 respondents. Then, once the responses are collected, these responses are uh, uploaded in Smart PLS 4, and then we got the analysis, and these are the analysis slide. First one is PLS SEM model. This model indicates the predictability level of our study. In left hand side, there is independent variables, that is regulatory clarity and ICT infrastructure maturity. And in right hand side, this is our, in green circle, this is our dependent variable, adoption of ICT enabled NFT accounting standards. In between, in blue circles, these are our, in upper one, this is our mediating variable, transparency in NFT financial reporting. And in lower blue circle, this is our moderating variable, legal framework strength. In rectangles, these are the questions that are being asked from the respondents. These are basically the questions in our questionnaire. In between rectangles and circle, these are the values. These are the values of correlation, and the cutoff limit for correlation is 0.50. If the values are more than 0.50, it suggests that our model is a good fit and could be used for further interpretation. And the values, that is 0.665 and 0.27, these are the values of regression coefficient. If these values are more than 0.50, it shows that our prediction level, there is moderate to strong predictive accuracy. And here the value is 66.5 and 62.7 times out of 100 times our value and our model predicts right. Basically, this table inculcates my entire findings. And the next slide is regarding the validity and reliability of our data. There are two major parameters. That first one is Cronbach alpha, and the second one is average variance extracted. The value, the cutoff limit for Cronbach alpha is 0.75, and for average variance extracted, it should be more than 0.50. And most of the variables are showing the values more than these. It means data is valid and reliable. And the next one is path coefficient. it basically shows the relationship between the variables, which is being showed by p-value. P-value shows the statistical significance of our data. If the values are less than 0.05, it means there is the data is statistically significant and our variables have a relation which is statistically significant. If the values are less than that, it means the data is not statistically significant. And here we can see that most of the variables are showing the value less than 0.05. This is the data analysis, and the last slide is regarding the conclusion. So here we can say that there is not much clarity about the regulations and ICT infrastructure, and there is also not any legal framework which supports the accounting of NFT. So the accounting bodies and government should more research on these topics and provide a good accounting framework for further accounting of NFTs. Here in our analysis, we have seen that our regression coefficient has a value more than 0.50, which indicates moderate to strong predictive accuracy and reliability of the framework. And the findings of the study includes that there should be a good regulatory clarity regarding NFT accounting, and there should be a good legal framework strength that also improves the trust of the investors, and the government also strengthen the regulatory policy and also enhance legal framework and also promote awareness among accounting professionals regarding the NFTs. So this is it from my side. Thank you.
Good, next, please.
Yes, ma'am. This was the last presentation. I would just like to close. Ayushi, ma'am, you can stop the screen share.
Okay, sir.
Yeah.
Few more were there, no?
No, it's over, ma'am.
Okay.
This was the last presentation which was missed before.
Acha. Yeah, second one. This was second one.
Yeah. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of this conference. We'll be very happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publications will be live within 7 to 8 months. So please kindly cooperate with the team of ICCTS 25. I also thank our session chair, Vidya Rani ma'am, for their knowledge and sharing of information. I would also like to share the token of appreciation. This is a certificate of a token of appreciation for the chairperson.
Thank you.
At the end, yes, ma'am. Any last words from you?
Really very good presentations were there, and everyone has worked a good and presented well. Your time management was also very nice, and I'm thankful to the organizers for inviting me and giving me this chance. Thank you. Wish you best of luck.
Thank you, ma'am. I kindly request everyone to please switch on their videos because I have to click a virtual photo. Thank you very much.